The sun shines down on our world, producing visible light, which we can see. Visible light is part of the electromagnetic spectrum, which includes infrared rays, ultraviolet rays, even microwaves, radio waves, and X-rays. However, most other forms of EM spectra coming from the sun are reflected or absorbed by Earth's atmosphere. Most of the light entering Earth's atmosphere and making it down to the ground is visible light, with the exception of some ultraviolet rays and infrared rays. When the sun is high in the sky, it produces white light. White light is a mix of all colors. When white light is put through a special kind of prism, the white light separates into all of its constituent colors. These colors are associated with different wavelengths of light, varying from 400 nanometers, which is blue light, and 700 nanometers, which is red light. When you see a rainbow, you see all the wavelengths of visible light. However, this does not include all the possible colors one can see. This is because of how the eye perceives color. The eye has three types of cells called cones, which perceive color. These are short cones, medium cones, and long cones. The short cones are best at seeing blue light. The medium cones are more sensitive to green light in the middle of the spectrum, and the long cones are most sensitive to red light. When light enters our eyes, it activates these cones in different amounts. Depending on how these cones are stimulated, the brain perceives different colors. For example, if only blue light is produced, the short cones are mostly activated and the brain perceives the color blue. When red light is produced, the long cones are most activated and the brain perceives the color red. However, when these two types of light combine, the brain perceives a new color called magenta. This color magenta is a mix of the two colors red and blue and is not associated with any particular wavelength of light. No one wavelength can produce magenta. This is true of many other visible colors, which are mixtures of many different wavelengths of light. Your phone or computer screen also takes advantage of the way your eyes see color to simulate color of a real object. For example, if you have a tomato, it will look mostly red, although there are many different wavelengths of light reflected off the surface of the tomato. Most of the light reflected off of it is toward the red end of the spectrum. However, when you look at a tomato on a computer screen, you only see a mixture of three colors: red, blue, and green. And it is mostly red light which you see. However, some blue and green light is added in. Because the colors of many objects can be simulated with just these three colors, they are called the primary colors of light. These three primary colors are red, green, and blue. This means that while we can see many different colors, our eyes actually cannot perceive all the dynamics of the spectra coming off of objects. Many different emissions of spectra can actually look like the same color if they activate the three cones in a similar way. However, not everyone can see and color the same way. Some people are colorblind. However, this is a bit of a misnomer because colorblind people can still distinguish and perceive color. They just can't perceive as many colors and cannot perceive the differences between as many colors as a person with normal vision can. You may have seen some of these tests before. These tests use designs based on different colors. However, colorblind people have difficulty distinguishing the differences between the colors, so it's hard for them to distinguish the designs. Different animals also perceive color in different ways. For example, birds and insects can actually see into the ultraviolet spectrum where human beings cannot. It's hypothesized that these animals use the ultraviolet light they can see to determine where to find nectar in different flowers. However, these species generally cannot see as well on the other side of the spectrum of red light as well as humans can. There is also a tendency in nature for carnivorous animals to not perceive color as well as omnivorous and herbivorous animals. Different colors of light also influence our behavior and our eyes in different ways. Blue light, whether coming naturally from the sun or from a screen, can keep us awake. This was the motivation for the development of the nightlight feature common in many phones and computers, where the application decreases the amount of blue light coming from the screen, making it look more red, and theoretically will keep the user from staying awake because of that light entering their eyes. Also, red light is much softer on the eyes in darker conditions. This is why on Navy ships, red lights are used below deck at night. Red lights are used because when it hits the eye, the pupils will stay dilated and the sailors will still be able to see in the dark.